Morning, everyone. I am Mahalya Kasturi from VITAP University in Integrated MTech. Today, I'm going to talk about an interesting topic in operating system about deadlock handling methods. Coming to the deadlock handling, it happens when two or more processes are stuck because each one is waiting for the other to release a resource. We can see in real based example, like in the below, we can see some cars are moving, right? Imagine two cars stuck on a narrow bridge from opposite side. Neither can move forward until the others back up. That's a deadlock. Then coming to the second slide, four main deadlock handling methods. There are first one is deadlock prevention and deadlock avoidance and deadlock detection and deadlock recovery. Coming to the next slide, we will talk about deadlock prevention. This method stops deadlock from ever happening by avoiding one of the four conditions needed for a deadlock. Here we can see mutual exclusion and hold and wait, no preemption, a circular wait. A mutual exclusion, at least one resource must be held. Like only one process can use a resource at a time. Then hold and wait. A process holding one resource, it waits for others. No preemption. Resource can't be forcibly taken from a process. Then circular wait. Process forms a circular chain waiting on each other. By breaking any one of these conditions, the system prevents deadlock from forming. We can see with a real based example, a traffic light control cars. So only one side moves at a time, preventing cars from blocking each other. We can see it in computers like the system may not lead a process, it holds one resource while waiting for another. Then coming to the second one, it's about deadlock avoidance. Here, the system checks every resource a request in advance to make sure granting it won't cause a deadlock. We can see with a real based example. Suppose a flight booking system. It only confirms a seat if it knows there's a safe way to complete the whole booking. In operating system, algorithms like Banker's algorithm, it analyzes the current state to decide if giving a resource is safe or not. Then coming to the third one, it's all about deadlock detection. Usually, this method allows deadlocks to happen, but keeps monitoring the system to detect them when they occur. And coming to the real based example, suppose assume that it's a factory. If two machines get stuck, they were waiting for each other parts. The supervisor notices, then it stands still and intervenes. In computers, the OS checks for circular waiting patterns among processes. Then finally, the fourth one is a deadlock recovery and ignorance. Once a deadlock is detected, the system takes actions to fix it, such as stopping one process or rolling back to a previous state. We can go with an example like if two cars were blocking each other, only one can reverse to clear the road, right? In computers, OS might terminate a process or it reclaims resources to free the system. Then ignorance. It sometimes system is simply ignores deadlock if they are rare or harmless. Like an example, in computers, like occasionally some small things freezes, right? It might be ignored because restarting clears them easily. This is often used in the systems like Windows or Linux, where full prevention can be too costly. Then coming to the advantages and disadvantages and deadlock. We can go with the advantages first, right? Then system design insight. Basically, it helps developers to find weakness in how resources are shared or scheduled. Like an example in traffic jams, usually it happens. Then improved resource management. I will go through with the example, then you can get a clarity. Like assigning parking spaces so cars don't block each other. Then testing concurrency. In ATM networks, like people people can use the same ATM network smoothly, right? Then security awareness. Example, finding out who can lock or unlock certain files or data in a shared system in your personal PCs or computers. Then coming to the disadvantages, a system freeze. It, it stops responding, which reduces performance and reliability. An example, if two codes stuck head to head on a LAN bridge, no one moves, right? Then resource wastage. Example, if a printer can start like a waiting for a file that never finishes, no one else can print. Then complex recovery. It fixes a deadlock, it may need restarting or rolling back process, which can cause data loss. Coming to real based example, restarting your computer because it freezes. You lost unsaved files like which you have done in your previous past like works. Reduce it throughout. The overall system slow down because task never finishes, like some tasks. Example, in a traffic jam, even cars not directly block, it moves slower, right? Then coming to the last slide, it's all about deadlock handling methods in a summary part. Then you can you can see prevention, avoidance, and detection like recovery and ignorance. Prevention, just a minute. It makes so deadlocks can't happen. Then avoidance. It checks every request to make sure it won't cause a deadlock. Like deadlocks happen, but watch for them. Then recovery. It fixes the deadlock after it's found. Ignorant. In some systems like Unix, like Unix, deadlocks are rare, so the OS may ignore them. Each method helps process run smoothly by managing how resources are shared among processes. Then finally, we can conclude it like we are going to discuss about deadlock handling methods. Firstly, we had discussed about the four methods and their advantages, and finally, then I concluded it. Thank you. Hopefully, I hope you understood.